Welcome to our lesson today on geometric series. Introduction. The school district emergency fan-out system is designed to enable important information to reach the entire staff of the district very quickly. At the first level, the superintendent calls two assistant superintendents. The two assistant superintendents each call two area superintendents, and they in turn each call two principals. We can see the superintendent starts, makes a couple of calls, this person makes a couple of calls, and so on. So the pattern continues with each person calling to other people. At every level, the total number of people contacted is twice the number of people contacted in the previous level. Now, this pattern can be modeled by something we call a geometric series, where the first term is 1. There's one superintendent to start this all off. And the common ratio, we'll talk about this a little bit more. The common ratio is 2 because each term will be multiplied by 2 to get the next term. The series for a fan-out system would be written like this. 1, so 1 for the first superintendent, who makes 2 calls. So 1 plus 2, and then plus 4, then plus 8, and so on, which gives a sum of 15 people contacted after 4 levels. Series relates to the word sum. We're adding terms in a geometric sequence, which gives us the series. Now, suppose we wanted to extend the pattern to other levels, such as 15, 20, or 100 levels. Well, we could extend the pattern. It might take us a little time, but to do so efficiently, because we like to do things efficiently in math, why don't we look at a formula? Because there is a formula for this, actually more than one. Let's just review. What is a geometric series? A geometric series is the expression for the sum of the terms of a geometric sequence. So the terms of a geometric sequence expressed as a sum is a geometric series. So for example, when you see these plus signs, 3 plus 6 plus 12 plus 24, we know that we got a series because we're adding these terms together. What's the formula? Let's start by the general geometric series and how it can be represented. So if we were to add, so we're going to use the letter S, so capital S, and a subscripted letter N to represent however many terms we want. So the sum of however many terms will be equal to the first term. T1 is the first term. Now the second term over here is T1 times something called the common ratio. The third term is the first one times the common ratio times another common ratio. And the pattern will continue. The fourth term is the first term times a common ratio times a common ratio times a common ratio, and so on, all the way down to r to the n minus 1. Now just suppose we're to multiply every term in the series by the common ratio. So if you look at this equation up here, we just multiplied every term by r. As you can see, every term by r. So now we have two equations. Suppose we subtract them, because we can take two equations and subtract them and come up with a new equation. So equation 1 we'll use as the r times s to the n, and there it is. And the other equation would be s to the n. And we line this up so that we can subtract all of these portions here. And by subtracting them, it would give us zeros. We'd zero it out. Well, what are we left with? On the left side of the equal sign, it would be r sn minus sn is equal to 0 minus t1, which is negative t1, all these zeros. And then down at the end, we'll just subtract this piece at the end that's only part of equation 1, which we get T1 times r to the n. We'll just rearrange on the right side. We'll put this negative t to 1. We'll subtract it, write it as subtraction, minus T1. So T1 Rn right here, minus this T1 on the right side. And over here, we'll factor out an Sn. And finally, we would divide both sides by r minus 1. And in doing so, we come up with this formula. The sum of n terms is equal to the first term multiplied by the common ratio to an exponent of n, the number of terms, minus 1, all divided by the common ratio minus 1. And just a little note that r, the ratio, common ratio, cannot equal 1. And there we go. We've got a formula. Wow. Pretty cool, isn't it? Now, you don't have to know how we got the formula. You'll just need to know how to apply it. Sometimes it is kind of interesting just to see how we get these formulas. We do have an alternative formula that we'll use sometimes. It's kind of handy. If the last term, or Tn, is known, we've got this other formula we can use that would still give us the sum of n terms. So T1 is still the first term, r is the common ratio, and Tn is the nth term or the last term. So let's look at some examples now. We got the first term, 64, common ratio is a quarter. So remember, the common ratio is the number that's multiplied by each term to get the next term. We want to find the sum of the first 8 terms of the geometric series. Now, since we do not know the last term, we're going to use this formula over here. So it's the first one we looked at. So we're going to sum n terms. We know the first term, we know the common ratio, and we know the number of terms. So we're going to put values in to this formula that we know. So we're going to sum 8 terms. First term is 64. We'll take the common ratio as a quarter and raise that to an exponent of 8 because there are 8 terms. We'll subtract 1 and divide by a quarter minus 1. So with our calculations, if you go to your calculator, go a quarter to the 8th and then minus 1. So we'll do the parts and brackets first. We multiply by 64. We should get this number right here, negative 63.999 repeating. A quarter minus 1 would be the same as a quarter minus 4 quarters, which would be negative 3 quarters. And dividing these two, we get this decimal that repeats. It's just rounded here, but it repeats. But if we were to press the fraction button in our calculator, it comes out to this fraction. 21,845 over 256. Okay, so that would be the sum of the 8 terms of this geometric series. Example 2, calculate the sum of the series. In this question, we know the last term, 10,935. It's t to the n, or the last term. C is written right at the end of the series. Now we know the first term is 5. T1 is 5. And to get the common ratio, take any term and divide by the previous term. So 15 divided by 5 gives us the common ratio of 3. We could also do 45 divided by 15. That's still 3, and so on. We're going to use this formula right now to find the sum of the series. So we got the formula. Let's substitute in. We know the 3. R is 3. The nth term is 10,935. The first term's 1, so we're going to, first term's 5, so we'll subtract 5 right here. All over the common ratio minus 1. So we do the substitution, and now just the order of operations on the numerator. We're going to multiply, subtract, and then divide that answer by 2. Okay, so our sum would be 16,400. Example 3, algebraically determine the sum of the first 7 terms of the geometric series. 27 plus 9 plus 3 plus ... Okay, so we don't know the last term or the nth term here. So let's look at what we've got, what we know. The common ratio is any term divided by the previous. So for example, we could go 9 divided by 27 and reduce that, we get 1/3. Common ratio is 1/3. First term is 27, T1 is 27. We're told in the question, n, or the number of terms, is 7. So which formula shall we use? Well, let's pick this first one again, because we don't know the nth or the last term. So we'll take this one. Let's substitute in what we know. First term's 27, right there. Common ratio was 1/3. We calculated that to an exponent of n, and n is 7. So 1/3 to the 7th minus 1, all divided by 1/3 minus 1. Okay, so find out the values we know, put them into the formula, calculate the top, calculate the bottom, and then divide. In doing so, we would get negative 26.987 ... on the numerator. That would be 1/3 to the 7th minus 1, and then times that by 27. All divided by 1/3 minus 1. 1/3 minus 3/3 would be negative 2/3. Again, we get a repeating decimal, 40.48 repeating. Or using the fraction button on the calculator will tell us that we get 1093/27 would be the sum of the first 7 terms of this geometric series. Example 4. Another way we could ask this is, how many terms do we have in the series? So we're going to be given the sum, in this case 342. We know the first term, we can figure out the common ratio. And then we have a bunch of information that we can use now to find how many terms. Common ratio is -4, term 2 divided by 1, term 1. So -4 divided by 2, right here. So common ratio is -2. First term is 2, and we know the sum. What we don't know is n, how many terms of the series. But we can find n. Which formula is required here? Which one do you think? Yeah, it's this one. Sum n terms, got the first term. We're looking for n, we got the common ratio. So we're going to substitute everything in. Our sum is 342. We know the first term is 2. Got the common ratio. And we're missing n. So we need to find out n here. Number of terms. So the way we would start this would be to try to get rid of this fractional component, which means we could take 342 and multiply by what's on this denominator, which would be -3. So -3 times 342 is -1026. Then we would divide both sides by 2 in order to try to get at this power here, this part in brackets initially. Isolate the power by adding 1 to both sides. And at this point, we're going to use guess and test. What exponent raised to a base of -2 would equal -512? And by doing so, we'd find that there would be 9. And that tells us that there are 9 terms in the series, which is what we were asked to find. In Math 30-1, we find out more efficient ways to solve for that exponent, that letter there. Number 5. Common ratio of a geometric series is 1/4, and the sum of the first 4 terms is 1275. So this is an example of where we're asked for the first term. I think in all previous questions here, we've been given the first term. but it's possible, given enough information, that we could find the value of the first term. So which formula? Well, we'll take this one because we don't know the nth or the last term. So we know the sum of n terms is 1275, so we substitute. We don't know T1, so we'll leave it at for now. Substitute a quarter for R, and that's raised to an exponent of 4 because we're told that we're after 4 terms. Minus 1, and then on the bottom would be R minus 1, quarter minus 1. Okay, so we've got everything now except T1. Let's use our algebraic skills now to isolate T1 and solve. So once again, let's take this denominator, a quarter minus 1, negative 3/4, and multiply it by the value on the left side here, 1275. And then we can take the part in brackets here, go a quarter to the 4th, subtract 1. We get this value, this repeating decimal that's in the brackets. So it's T1 times this number is equal to negative 956.25. So to find T1, let's divide both of the sides of the equal sign by what's in brackets here, negative 0.966 ... And if we do that, we get exactly 960 for T1. We make a final statement to say the first term is 960. Let's conclude with an application. How would this look like more in a situation? Suppose there are 512 people participating in a Scrabble tournament. A word game. If you like word games and letters, Scrabble is quite the fun game, actually. The format is such that the losers of each round are eliminated from the next round, and the winners continue to play until a final match determines the ultimate Scrabble champion. So we're asked two things. What is the total number of rounds and the total number of matches that will be played in the tournament? Okay, so rounds and matches. So let's start with this. We've got 512 people, and every match requires 2 people. So there will be 256 matches in round 1. So that's our starting point here. Right? 2 people are required to play a game or a match. So take the total number of people, divide by 2. So you got 256 matches in round 1. 256 in the first. Then what do we do in the second round? Half are eliminated, half move on. So divide by 2. Take 128, divide by 2. So we continue to divide by 2 until we get down here to only 1 match left. Okay, so Tn is represented at the end as with 1 match. So what do we know? So every term is, divide by 2, but we think of geometric sequences and series as the common ratio as a multiplier number. It's a factor. So yes, we're dividing by 2, but we're multiplying by 1/2. Let's think about it as multiplying by 1/2. So R is 1/2. T1 is 256. That's the number of matches initially. T1 is 1. Now we need to find the number of terms, n, which will give us the answer to the first part of the question, which is the number of rounds. Okay, n will give us the number of rounds. So we're going to use the general term of a geometric sequence to determine n. So this would have been covered in a previous lesson. The general term t to the n is equal to the first term t1 times the common ratio to an exponent of n minus 1. So we know that T1, we're going to end up with 1. We're going to start with 256. We have an exponent, or sorry, we have a ratio, common ratio of 1/2. The exponent is n minus 1. So once again, we'll use guess and test here to find the value for the exponent. We can determine that n is equal to 9. Right, so that tells us we've got 9 rounds. The total number of matches per round follows a geometric series now. Now we're after the total number of matches, which is different than the rounds. So 256 matches initially, first round, and then 128, then 64. So we're adding these up. So we need all these numbers, and we're going to use the formula to find the rest of these numbers for us. So we'll use this formula. So we substitute the sum of 9 rounds because n is 9. We found out n was 9. Sum of 9 rounds. 256 in brackets. 1/2 is a common ratio to an exponent of 9. Right? N is 9. Minus 1 all over 1/2 minus 1. If we do the calculations, 1/2 to the 9th minus 1 multiplied by 256 and then divided by 1/2 minus 1, we should get the sum of 9 rounds, or the sum of 9 terms, to be 511. So we state at the end, we have 511 matches. The summary. The geometric series is the expression for the sum. Just pause there. The sum. Series, sum. We're adding. The sum of the terms of a geometric sequence. So for example, 5 plus 10 plus 20 plus 40 is a geometric series. The general form for the sum of the first n terms is Sn is equal to T1 bracket r to the n minus 1, all divided by r minus 1. R cannot be equal to 1. T1 is the first term, r is the common ratio, n is the number of terms. Or we do have another formula we could use. If the last term, or t to the n, is known, we can use this formula. R times t to the n minus t1, all divided by r minus 1. We use this formula when the common ratio r, the first term t1, and the nth term or last term tn are known, but the number of terms is not. So that concludes our lesson here on geometric series. Hope that you enjoyed it. Hope that you have a good understanding of it. And until next time, have yourself a great day.